Welcome to Hexagon Tutorials Dart series. In this video, we will be studying Object-Oriented Programming. Object-Oriented Programming, or OOP, is a powerful programming paradigm that revolves around objects. These objects serve as building blocks containing both data, known as properties, and functions called methods that operate on this data. Let's break down the core concepts of OOP. A class acts as a blueprint or template for creating objects. It defines what properties and behaviors an object will have. An object is a real-world instance of a class. Each object has its own unique values for the properties defined in the class. Properties, also known as fields, are variables inside a class that hold data. These define the characteristics of an object, like a person's name or a car's color. Methods are functions within a class that determine the behavior of an object. They allow objects to perform actions like processing data, updating properties, or interacting with other objects. By following OOP principles, we can write code that is well-structured, reusable, and easy to maintain, making development more efficient and scalable. In Dart, a class is a fundamental part of object-oriented programming. It acts as a blueprint for creating objects, defining their properties and behaviors. Let's go through each component of a class in detail. A property, also called a field, is a variable inside a class that holds data. Each object of the class has its own set of properties. The data type of a property defines what kind of value it can store. For example, in a class representing a car, properties could include the car's color, speed, and price. Next, we have the constructor. A constructor is a special method that is automatically called when an object is created. Its main purpose is to initialize the properties of the object. The constructor has the same name as the class and does not return any value. If no constructor is explicitly defined, Dart provides a default constructor. By using constructors, we ensure that objects are set up correctly when they are created. The methods inside a class define what actions an object can perform. Methods are functions that can interact with properties, perform calculations, or modify the object state. For example, in a class for a car, a method named drive could increase the speed, while a method named brake could decrease it. When an object of a class is created, the constructor initializes its properties, and methods allow us to interact with and manipulate the object. This structure helps keep code organized, reusable, and easy to manage. By using classes, we can create real-world models in our programs, making the code more structured and scalable. In this Dart program, we define a car class, which serves as a blueprint for creating car objects. Inside the class, we declare three properties: brand, color, and year. These represent the characteristics of a car. Next, we define a constructor using the this keyword, which initializes these properties when a new object is created. The constructor takes three arguments: brand, color, and year, and assigns them to the respective properties of the object. We also define a method called displayInfo. This method prints the details of a car, displaying the brand, color, and manufacturing year. In the main function, we create two car objects. The first car is a Tesla, red in color, manufactured in 2023. The second car is a BMW, blue in color, manufactured in 2020. After creating these objects, we call the displayInfo method on both, which prints their details to the console. This example demonstrates the power of classes and objects in Dart. By defining a class, we can create multiple objects with different values while keeping the structure organized and reusable. This approach makes the code more scalable and easy to maintain. This keyword in Dart is a powerful tool that refers to the current instance of a class. It plays a crucial role in differentiating between instance variables and constructor parameters or local variables when they share the same name. Without it, Dart may not correctly assign values to the instance variables, leading to unexpected behavior. Why do we need this? Let's consider a scenario where we define a class named person with two properties, name and age. To initialize these properties, we pass values through a constructor. However, if the constructor parameters have the same names as the instance variables, a problem arises. For example, in the following class definition, a class named person has two instance variables, name and age. Inside the constructor, we attempt to assign values to these variables using the same parameter names. However, Dart does not automatically recognize which name refers to the instance variable and which refers to the constructor parameter. As a result, the assignment does not work as expected, and the instance variables remain uninitialized or null. This happens because Dart gives priority to the local constructor parameters, treating them as independent variables rather than modifying the instance variables. To solve this, we need a way to explicitly refer to the current instance of the object, and that's where the this keyword comes in. To ensure that the correct values are assigned, we use the this keyword. With this, we explicitly tell Dart that we are referring to the current object's instance variables, not the constructor parameters. For example, in an improved version of our person class, by using this .name is equal to name, we make it clear that the instance variable name should receive the value of the constructor parameter name. The same applies to age. Now, when we create an object like a new person object is created with the name Elise and age 25. Since we correctly assign the values using this, the object now holds Elise as the name and 25 as the age. This ensures that our constructor works as intended, making the code clear, efficient, and bug-free. Let's take an example of a car class, where each car has three properties: brand, color, and year. When an object is created, the constructor initializes these values. However, what if we want to change the color of the car after it has been created? How property modification works. First, an object car1 is created with the brand Tesla, color red, and year 2023. The displayInfo method prints the car's details. We then modify the color property of car1 and change it from red to yellow. When displayInfo is called again, it now reflects the updated color yellow. This demonstrates that instance properties can be modified after object creation. Such modifications are useful when we need to update object attributes dynamically during runtime. A constructor is a special method that gets called automatically when an object is created. It helps initialize the object with default values. Now, if you don't define a constructor in a class, Dart automatically provides a default constructor. This means you don't have to manually write one, it's there by default. Let's break down its key features. A default constructor doesn't take any parameters. That means you don't need to pass any values when creating an object. If no constructor is defined in a class, Dart creates one automatically. It ensures the object is initialized properly with default values. Now, when should you use a default constructor? When you simply need to create objects without passing any arguments. When you want Dart to handle initialization automatically, so you don't have to set up values manually. So in short, the default constructor is a simple and efficient way to create objects without extra effort. It ensures that every object starts with an initial state even if you don't explicitly define how it should be constructed. In this example, we have a class called dog. Inside this class, we have two properties, name and age. The name property is set to Bruno by default, and the age is set to 2. Now, we also have a method called bark, which prints a message showing that the dog is barking. Since we haven't defined any constructor in the dog class, Dart automatically provides a default constructor. This means that when we create an object of the dog class using dog mydog is equal to dog, Dart will use the default constructor to initialize the object with its default values. Here, dog is a constructor call that creates a new instance of the dog class. In the main function, we create an instance of the dog class called mydog. Then, we call the bark method using mydog.bark. Since the name property is already set to Bruno, the output will be Bruno is barking. This example shows how a default constructor works in Dart by automatically initializing an object with default values when no custom constructor is defined. In Dart, we have something called named constructors, which give us more flexibility when creating objects. Unlike the default constructor, which Dart provides automatically when no constructor is defined, named constructors allow us to define multiple ways to initialize an object. Now, why do we need named constructors? Well, sometimes we might want to create an object with different initial values based on certain conditions. Named constructors make this possible by allowing us to set up different initialization methods inside the same class. For example, imagine we're working with a class that represents a car. One named constructor could initialize the car with default values, while another named constructor could set values based on an older model. This means we can create objects in different ways while keeping our code clean and organized. The best part about named constructors is that they make our code more readable and structured. Instead of relying on just one constructor, we can have multiple ones, each with a clear purpose. So, in summary, heavy checkmark named constructors allow multiple ways to initialize an object. Heavy checkmark, they help set specific values at the time of object creation. Heavy checkmark, they make our code more organized and easier to understand. By using named constructors, we can write better, more maintainable code while keeping things flexible and efficient. We are using named constructors in Dart to provide an additional way to initialize an object of the rectangle class. The class has two properties, width and height, which represent the dimensions of the rectangle. We define a regular constructor that initializes these properties when values are passed during object creation. However, in some cases, we might need a special type of rectangle, a square, where both width and height are equal. Instead of passing to identical values every time, we can create a named constructor called square. This named constructor takes a single parameter, size, and initializes both width and height to this value. This makes it easier to create square-shaped rectangles without repeating the same value twice. In the main function, we first create an object using the regular constructor, passing separate values for width and height. Then, we create another object using the named constructor square, passing only one value, which sets both width and height equally. Finally, we call the display method to print the dimensions of both rectangles. This code shows how named constructors allow us to create objects in multiple ways, making code more readable and efficient. Alternative approaches. Using the late keyword. If we want to initialize fields inside the constructor body rather than in an initializer list, we can declare them as late. This allows us to delay initialization while still following Dart's null safety rules. Another way to avoid initialization issues is by making the fields nullable using. This way, Dart does not require them to be initialized immediately. Let's talk about parameterized constructors and why they are useful. A parameterized constructor allows you to pass values while creating an object, making it much more flexible compared to a default constructor. Instead of relying on predefined values, you can initialize an object with specific values right at the time of creation. This is particularly helpful when you want different objects to have different properties based on the input provided. Now, let's go over some key features of parameterized constructors. First, they allow you to pass arguments while creating an object. This means that instead of manually assigning values after creating the object, you can set them immediately. Second, they help in initializing instance variables with specific values, ensuring that an object starts with meaningful data. And finally, they provide more control over object creation by making sure the required data is passed when an object is instantiated. So, when should you use a parameterized constructor? You should use it when you need to initialize an object with custom values instead of relying on defaults. It is also useful when different objects should have different initial values, such as when data comes from user input or an external source. And most importantly, a parameterized constructor ensures that all necessary values are provided right at the beginning, preventing the possibility of missing or uninitialized data. Overall, parameterized constructors make object creation more efficient, flexible, and structured, giving you better control over how data is assigned at the time of instantiation. Here's how we typically define a parameterized constructor. We create a constructor that takes parameters and then assigns those values to the instance variables inside the constructor body. This method works fine, but it requires writing extra lines of code to manually assign values. Now, there's a better and more concise way to achieve the same result by using the this keyword in the constructor parameter list. Instead of assigning values inside the constructor, we directly use this.width and this.height in the parameter list itself. This automatically initializes the instance variables, making the code shorter, cleaner, and easier to read. So, while both approaches work, using the this keyword is the preferred method as it eliminates redundancy and improves code efficiency. A factory constructor is a special type of constructor in Dart that provides more control over how objects are created. Unlike a regular constructor, which always creates a new instance of a class, a factory constructor can either return a new object or return an existing instance based on specific conditions. This makes it highly useful in scenarios where object creation needs to be optimized. Now, why do we use a factory constructor? One of the key reasons is to return an existing instance instead of creating a new one every time. This is particularly useful in situations where multiple parts of a program need access to the same object rather than creating duplicates. Another important use case is when we need to perform some logic before creating an object. For example, if we are fetching data from an API or a database, we might want to check if the data is valid before creating an instance. Factory constructors are also widely used for implementing the singleton pattern, which ensures that only one instance of a class exists throughout the application. This is helpful in cases like managing a database connection or a network service where multiple instances would be inefficient. Additionally, when working with APIs or databases, a factory constructor allows us to control object creation based on external data. If certain conditions aren't met, instead of creating a new instance, we might return a pre-existing one or even throw an error. Now, let's talk about the key features of factory constructors. First, they are declared using the factory keyword, which distinguishes them from normal constructors. Unlike regular constructors, they don't always create a new instance. Instead, they can return an existing object or even an instance of a subclass. They allow us to perform additional logic before object creation, such as validation, caching, or applying conditions before returning an instance. When should you use a factory constructor? When the object creation process is complex and requires conditions. For example, if creating an object depends on fetching and validating data from a database, a factory constructor allows us to handle that efficiently. When you want to control the number of instances, like in a singleton pattern, where only one instance of a class should exist. When working with APIs or databases, where object creation might depend on whether data is available or not. Instead of creating unnecessary instances, we can return an existing one or handle errors properly. So, in summary, factory constructors provide more flexibility and efficiency in object creation, making them a powerful tool in Dart for managing resources, optimizing performance, and ensuring better control over how instances of a class are created and managed. In this code, the circle class has a private constructor and a factory constructor to control object creation. The private constructor ensures that instances cannot be created directly from outside the class. Instead, the factory constructor handles object creation with additional validation. Inside the factory constructor, we check if the radius is less than or equal to 0. If it is, an error is thrown, preventing the creation of an invalid object. If the radius is valid, the factory constructor calls the private constructor to create an instance. In the main function, we try to create two objects, one with a valid radius 5 and another with an invalid radius -3. The first object is created successfully and its area is printed. The second attempt triggers an error, which is caught and displayed. This approach ensures that only valid circle objects are created while preventing direct access to the constructor. Let's talk about the singleton pattern in Dart. A singleton is a design pattern that ensures only one instance of a class is created and used throughout the application. Now, why is this useful? Well, in many cases, we need a single shared instance instead of creating multiple objects. Some common examples include database connections, logging services, or configuration managers, things that should have a single consistent instance across the app. Why should we use a singleton? First, it ensures that only one instance of a class exists at a time. That means instead of creating multiple objects, the same instance is reused whenever needed. Second, it helps in saving memory because we're not creating unnecessary duplicate objects. Instead, we just access the existing instance, which improves efficiency. And third, it's useful for maintaining a global state throughout the application. If you need a centralized resource that should remain the same across different parts of your code, a singleton is the perfect choice. How to implement a singleton in Dart? There are two common ways to implement a singleton in Dart. Using a private constructor. The first approach is by using a private constructor. This works by declaring a static instance of the class inside itself. The constructor is private, which means objects cannot be created directly from outside the class. We provide a static method or getter that allows access to the single instance. This ensures that whenever we try to get an instance of the class, we always get the same one. Using a factory constructor. Another way to implement a singleton is by using a factory constructor. We still declare a static instance inside the class. Instead of a normal constructor, we use a factory constructor that returns the same instance every time. If an instance doesn't exist, it creates one. Otherwise, it simply returns the existing instance. This method ensures that only one object of the class is ever created. Both of these approaches help in controlling object creation and make sure that there is only one instance of the class being used throughout the application. When should you use a singleton? A singleton is useful when you need a single shared resource that should not have multiple instances. For example, when working with a database connection, a singleton ensures that only one connection is maintained throughout the application rather than opening multiple connections unnecessarily. Another common use case is managing global state, such as app configurations or authentication. Having a singleton for these ensures that the same data is accessed consistently across the application without needing to pass it around manually. A singleton is also helpful when you need to ensure consistent access to a resource without creating redundant instances. This prevents unnecessary memory usage and keeps the application more efficient. In short, the singleton pattern provides a single point of access to an object, ensuring that only one instance exists and is shared efficiently across the application. Alright, let's start by creating a singleton class in Dart. First, we'll define a class called logger. Inside this class, we need to make sure that only one instance of this class can ever exist throughout the application. To do this, we'll create a private constructor. A private constructor is defined by adding an underscore before its name like this. This prevents the class from being instantiated from outside. Next, we need a static instance of the logger class. This will hold the only instance of our singleton. Since it's static, it belongs to the class itself and not to any particular object. Now, to ensure that every time we try to create a logger object, we get the same instance, we use a factory constructor. The factory constructor checks if the instance already exists. If it does, it simply returns the existing instance. Otherwise, it initializes it for the first time. Let's also add a simple log method inside our class that will print messages. This will simulate how logging works in real-world applications. Now moving on to the main function, we'll create two objects of logger. But because of our singleton implementation, these two objects should actually be the same instance. Let's log a message using one of them. And finally, to verify that both logger1 and and logger to refer to the same object, we'll use the identical function. If our singleton is working correctly, it should return true, indicating that both variables hold the same instance of the logger class. Now let's check the output. The first line will print the log message as log hello world, and the second line will return true, confirming that both objects are indeed the same instance. And that's it. We've successfully implemented a singleton in Dart using a private constructor and a factory constructor. Now, no matter how many times we try to create an object of this class, it will always return the same instance. Thanks for watching. Do like, share, and subscribe to follow more such content.